let's say for a project, I need to make a bunch of cubes. Maybe it's for like a children's toy design thing or something like that. And I'm interested in adding up the volume of all these cubes. So let's see if there's like a more compact way to do that. And in fact, of course there is. So what it's gonna look like, okay, it's gonna have this sigma notation. And so it just basically stands for sum. It's obviously a Greek letter. Okay, so the bottom thing is what's called an index. I'll use I on this one, but it's often J or K are also used for this variable. Sometimes N, because N is an integer. And you'll see that this variable starts at this value and then steps up by integers to the top value. Okay, so let's say I'm interested in adding the volumes of those cubes. Okay, so the first one would have a volume of like, 1 cubed, then we're 2 cubed, 3 cubed, 4 cubed. Okay, but I want to just do that sum all compactly with like one expression. Okay, so I'm going to start with I equals 1, and I'm going to go from 1 to 4, so I'm enumerating the variable I takes this value, then it takes that value, then it takes that value, then it takes that value. So it sounds weird, but this, when I expand it out backwards, is going to be, so first I start with I equals 1, so I plug that in, it's going to be 1 cubed. Then the next thing I do is I go I equals 2, so I'm going to add 2 cubed. The next thing is 3, so I'm going to add 3 cubed, right? And the next thing is 4, so I'm going to add 4 cubed. Okay, so it actually add those numbers up. Okay, so it's just going to be 1 plus 8 plus 27 plus 64. Okay, so how funny, kind of gives a nice answer for this one. You're going to get 100 for the sum of those first four integers cubed. Okay, so we'll do some more examples of this in a minute. Okay, let's look at this problem. Okay, so what this is telling us to do is to start with the value of n equals 5, then evaluate this, then step to n equals 6, then evaluate this, then step to n equals 7, then evaluate that. Okay, so it's going to look like this. So that's when n equals 5, okay? And so if I go ahead and evaluate that out, so that's going to be 25 plus 10, that's going to be 35. Okay, let's go ahead and write that out. Okay, the next thing I want to do is look when n equals 6. Okay, so when n equals 6, I'm going to have 10 plus 5 times 6. I'll write that out. Okay, so that's going to be 30 plus 10, so that's going to be 40. And then the last one is to evaluate it when n equals 7. So that's going to be 10 plus 5 times 7. That's going to be 35 plus 10. That's going to be 45. Okay, so to get that final sum, I would want to add those three numbers all together. Okay, so you might be able to do that in your head. That's going to be 120. Okay. Okay, let's take a look at these two summations and kind of walk through what they are. Okay, so this is I equals 4 to 6 of I cubed. So I plug in I equals 4, I'm going to get 4 cubed. Then I step to 5, I'm going to add in 5 cubed. Then I step to 6, I'm going to add in 6 cubed. Okay, let's look at this one. Here I start at 5. Okay, so the first thing is going to look like 5 minus 1 all cubed. Then the next one is going to be 6 minus 1 all cubed, and then 7 minus 1 all cubed. Okay, so once I, of course, simplify them, I just get 4 cubed plus 5 cubed plus 6 cubed. Okay, so the upshot of this example, okay, if you look at these really carefully, they're really describing the exact same thing. So again, it's one of those situations where if you put something into sigma notation, there might be more than one way to do it, especially if you play with the starting indices in different ways. you might notice that these are all one higher, but the way it works is like the first thing I do is make it all one lower. So it kind of compensates. If these are all one higher, if then first thing I do is, well, I'm going to now make them all one lower. It kind of works out so they're all the same. But anyway, the point is one answer might not look like somebody else's answer. You know, they all have to kind of be graded individually because there might be, you know, many ways to do a problem like this. All right, so if you have something like this one, of course there can be many ways to do it, okay? So one thing you might be able to think of is that, you know, hopefully you can relate this to an arithmetic sequence. Okay, so let's say that there could be many ways to do it. One person might be like, let me start at n equals 0, okay? And then you see that you're adding 10 each time. They might do it like that, okay? And that would be okay. They started at 0. If I plug in 0, when you're allowed to use 0 with sigma notation, by the way, then when I plug in n is 0, then I get 75 for my first thing. Okay, so if I did that, it would be 0, 1, 2, 3 would be the way to spell out the terms. And of course, I should really double check every time I do it. You know, go ahead and plug in n equals 0, I get 75, n equals 1, 85, n equals 2, 95, and n equals 3, 105. You know, if it's small enough like that, you can double check. Okay, another person might do it, you know, a different way that would also work. And of course, you've seen this many times before. Let's say they started with n equals 1, then they'd probably go to 4, right? So 1, 2, 3, 4. In this case, what you're going to have to do, you could do it this way. You could do 75 plus n minus 1 times 10. And of course, you can see exactly that it follows that arithmetic formula for the nth term of a sequence. You know, you put the first term in, so you see that it's just like the formula for the arithmetic sequence, finding the nth term. You take the first term, and then you add in n minus 1 common ratios, and then of course here you're starting with n equals 1. But the point is, you could do it with this method, and that would be fine, and that answer would be 100% correct. You could do it with this method, it's totally fine, that answer would be 100% correct. Obviously you could do it infinitely many other ways, and they would be correct. But if you're comfortable, you just like those formulas and so forth, maybe that's the way to go for one that's like that.